Hi, I'm Scott with Confluent, and on the screen you see three acronyms. They probably look familiar, and they stand for Confluent, MongoDB, and Google Cloud Platform. I'd like to do something a little different this time than just splashing up slides and telling you about the platforms. I'd like to get hands-on with a publicly available GitHub repo that you can try yourself. No hidden code, no internal shortcuts. Now, you might already be familiar with all three companies, so I won't spend too much time on the intros. But before we dive into the terminal, let me just say a quick word about each and how they fit into this particular demo. Confluent Kafka, this is the event streaming backbone. We're using Confluent Cloud, the fully managed version of Apache Kafka, to handle real-time data movement between services. And it's not just about transport, we're also using Flink to enrich and transform data in flight. And on a personal note, as I mentioned, I work here and can talk about Confluent ad nauseum. So if you'd like me to do that for you, just let me know. And MongoDB Atlas is our operational database here. And like I said, we're using Atlas, the fully managed cloud version. What's cool is that MongoDB Atlas now supports vector search and a number of other things. But this lets us do, in this demo, retrieval augmented generation, or RAG, by storing and querying text embeddings. And while it's not in this particular demo per se, I'd like to call out that MongoDB, much like Confluent and GCP, are making rapid advancements in AI. Something you should check out is Voyage AI with its advanced LLM capabilities. And that's not just embedding generation, but includes other features like re-ranking, sorting, and even industry/vertical specific models. And Google Cloud. We are using Vertex AI, Google Cloud's enterprise AI platform. Under the hood, it's calling Gemini, Google's large language model, but using it through the Vertex AI gives us production-grade features like IAM, regional control, and serverless scaling. One of the things I love about Gemini is that it too is making huge advancements in AI. And I like to use the image and text processing in tandem. And, while not demoed here, it's something I'd recommend you check out in your own time. So together, these three platforms, Confluent Kafka, MongoDB Atlas, and Vertex AI, along with the other things that I highlighted that aren't in this demo, but I like to call out because they're really cool, exciting features that I suggest you check out on your own time. But these three form a streaming, searchable, generative AI pipeline. So let's see how all of that comes together. All right, I'm going to walk you through deploying the MongoDB, Confluent, Google Cloud Platform Quickstart. We will use this GitHub repo from Confluent, which shows how to combine real-time streaming with generative AI on Google Cloud. This script bootstraps the entire pipeline, and I'll show you how that works. It provisions resources in GCP, it sets up MongoDB Atlas, it configures Confluent Cloud and the required connectors, and deploys a simple application. All right, let's do ourselves a favor and open up a new terminal screen, and let's see what folder I want to go. I think I have a GitHub folder. I do. So let's go into that, see what's in there. Great. So we've got a clean directory. Let's start with that, and let's git clone the URL that I showed you previously. Okay, that is done, and you can see I've got my new directory. So let's go ahead and go into that. Great, and I've got some files, and according to the README page, all I need to do is run deploy.sh. So let's do that now. Terrific. Now I'm being prompted to enter my credentials, so I need to go get those and paste those into the screen. And off to the races we are. So while that's running, I want to flip over and show you a couple of slides to talk through while this is deploying. Okay, just very briefly, while that runs, here's what we're deploying under the hood. This architectural diagram shows how MongoDB Atlas, Confluent Cloud, and Google Cloud Platform come together. We ingest data from MongoDB using source connectors into Confluent Kafka. Flink enriches that data in motion, for example, adding embeddings. And then that enriched payload is routed and stored into MongoDB for vector search. And we send that to Vertex AI for summarization or Gemini for generation. And this is the full stack. It's an operational database, it's event streaming, it's large language model processing, and vector recall, all deployed on Google Cloud Platform. So that was kind of a generic diagram, just an overall architectural diagram of the three platforms. This slide's a little bit different. This is the slide that accompanies the actual GitHub repo. This architecture slide is in the repo itself. And this is the streaming RAG or retrieval augmented generation flow that we're showcasing. In this case, user input flows through a WebSocket into Confluent Kafka. Flink enriches the message and calls Vertex AI to generate embeddings. A vector search is done against MongoDB Atlas to find the most relevant context. And then that context, along with the original query, is passed to Gemini via the Vertex AI for response generation. That result is then streamed back, enabling a fully real-time serverless RAG architecture. And this is production-grade architecture, not just a prototype. We use Vertex AI instead of the simpler Gemini developer API, so we can take advantage of IAM roles, regional control, and scalable integration with GPC services, like we mentioned before. Okay, flipping back to the terminal, it looks like our deployment has been successful, but the proof is in the pudding. So let's fire up this front end and check it out. There is a URL that has been provided in the output. So if we copy that, we should be able to put that into a browser and try it out. So let's do that now. Okay, great. So I've taken that URL that you saw and I've posted that into my browser, and up comes my demo. So let's run this demo by sending in a message and watch how it flows through Confluent Kafka, gets enriched and embedded, performs a vector search, and gets completed by Gemini. Everything's in real time and event driven. To save you the trouble of watching me type very slowly, I have written something out in advance that I got from a colleague of mine that actually created this demo. I thought this was really neat. So I will not reinvent the wheel, and I will just use what I got from my colleague. And I will click this ship airplane icon and watch the response come back. So here's what I put in. Pretty long description. Sounds pretty bad. The symptoms, that is. And so, yeah, response came back. That sounds really unpleasant. Yeah. And definitely concerning. And then it asked me a couple more questions. It wants to get a little bit more context. So I think what's really cool about this is it's kind of like, welcome to this medical knowledge assistant. And this repo offers the step-by-step guide to deploy this fully functioning chatbot, which helps identify medications, their side effects, dosages, and other essential information to determine the best treatment for the illness that I'm describing here on the screen. So I could go further and further with this chatbot, but you get the idea. So when you spin it up, feel free to play with it and give it a rip and see what you think. Before we end this session though, let me take a minute to show you a little bit about each platform. In Confluent Cloud, you will be able to see your Confluent Cloud Kafka topics, connectors, the Flink application that's running. And in MongoDB Atlas, you're going to be able to inspect the collections, see what the data and embeddings are, and that are used in the vector search. And in the GCP console, you're going to see what services have been deployed. And Vertex AI is available with your IAM linked service accounts. So let's check out what this looks like when I click into these applications. Okay, first things first, I'm looking at Confluent Cloud. And let's just briefly take a look. I've got a couple of environments running. Here's the Gen AI Quickstart that we just launched. And in it, I can see I've got a cluster running. And I can actually click here on the link and see my Flink compute pool and also look at statements that are currently running and in flight. I can click on those and look at the SQL content of these. So you can quickly get around. Let's go back to this cluster and dig into that. I've got number of topics, as you can see here. I've even got information on my connectors that I can look at. So very easy to use. Let's flip over to MongoDB. Okay, logged in. And what have I got here? My Gen AI Quickstart app. Let's browse the collections on those. And here we are, medications summarized with embeddings. So if I scroll down, we better see some embeddings in here. This one is ibuprofen. Ah, here we go. Embeddings, array of 768, which is coming from my LLM that I used with this GitHub repo project. So you could have any number of embeddings that you choose for your model, but that's definitely working. So very cool to see that there. And if I scroll down, I can see more and more. Finally, let's jump over to Google Cloud Platform. And as I log in, sure enough, I get to see my project. There's the project ID that I input when I run the deploy.sh from earlier. And I can see a number of other services that I run. I can actually go out to my Google Cloud dashboard and drill into any number of things here, like APIs and services. I can see, oh, great, I've got a number of other services that I am having throughput through because I'm using. So very cool. I can see it all. So this is kind of neat. And this will be useful too as you tear things down to see all of this go away. And we'll do that next. Great. So now that we've taken a look at the platforms and just giving you a very quick overview of it, let's tear things down because we are cost conscious and we want to avoid running resources unnecessarily. And I'm done with this demo. So I encourage you to remember to do this as well. It's in the README file. It tells you to destroy it, but it's always good to mention it. So let's take a look at what files we have here. And sure enough, we have destroy.sh, which again in the README tells me to run that. So let's go ahead and remove our application. Now, this thing will tear all the services down. So you should be feel comfortable that you will be all cleaned up and back to your baseline before you could even run this GitHub. So this will take a little bit, so we'll let this run. But I hope you have enjoyed this session and kind of giving you a quick start into the quick start. So a jump start rather into just getting your hands going. Don't hesitate to try it out and hope you enjoy.